Welcome. Today we'll find the derivative of the function h of x equals natural logarithm of x plus the square root of x squared minus 1. To differentiate this function, we'll need to use the chain rule, since we have a composition of functions. The chain rule states that if we have y equals natural log of u, then the derivative dy dx equals 1 over u times du dx. In our case, u equals x plus the square root of x squared minus 1. Let's identify this as our inner function. Now, applying the chain rule, h prime of x equals 1 over u times the derivative of u with respect to x. To find the derivative of u, we need to use the sum rule and the chain rule again. The derivative of x is simply 1. And for the square root term, we'll need to use the chain rule with the power rule. For the derivative of the square root, we use the chain rule. 1/2 times 1 over the square root of x squared minus 1 times the derivative of x squared minus 1. The derivative of x squared minus 1 is 2x. Simplifying the fraction in the parentheses, we get 1 plus x over the square root of x squared minus 1. Now comes the amazing part. After all this work, when we multiply these expressions and simplify, we get a surprisingly simple result. H prime of x equals 1 over the square root of x squared minus 1. This is a beautiful example of how a complicated-looking function can have a relatively simple derivative. The key to solving this problem was careful application of the chain rule and algebraic simplification.